Hi, my name is Rebecca Lindell, and I am the current chair of PERLOC, the Physics Education Research Leadership and Organizing Council. And what we have started doing now in 2025 is we had heard from the town hall meetings we had that people were wanting to hear more discussions, more things about what is actually happening in research and skills that they can master for that. So for this time, we are actually starting in the months of October and one in November. We are having what we call community conversations, where we come together as a group, we listen to somebody speak, and then we interact and talk about what we're hearing, what we're thinking, what are issues that you might have. Today we have Valerie Burton out.
Woo!
Whoops. Valerie Otera, who is a good friend of mine, will forgive me. Hopefully forgive me.
No problem. Some people often mistake me for Heather Locklear also.
I used to always get mistaken for Molly Ringwald. Like little kids would come to me, you look like Molly Ringwald. And I'm like, oh, thanks. Anyway, what I was going to say is that Valerie and I have known each other I was thinking about it last night. We've known each other for over 25 years. And actually even more than that, because she said that she has been in physics education research for 30 years this year. And I hit 30 years next year. Valerie, when I first met Valerie, I'm going to share this story, I remember, I don't know if I'd met her before this or not, but I remember going to her talk, and I think it was at the San Antonio AAPT group. It was either an invited talk or part of the third perk that was happening there. And she's in this room, and funny thing about it is this room was large enough to house everybody. And there was like 50, 60 people in there, big room. And she gives this talk. And she gives a talk about her research. And her research is talking about ethnographic research, qualitative research. Now, I, as a qualitative researcher, also was having problems conveying that, hey, this is a worthwhile thing to do. It's not just interviewing students and trying to do a thematic analysis. There's much more into that. And she's giving this talk. And it's just like, I thought she was like one of us. No, she was like a firebrand. She was so passionate about this. She was so intensive. And I remember at the end of the talk, Joe Ryder stood up, if you remember Joe, who was at the time one of the senior members of the physics education research community, and he stood up and he's like, wow, I think you just just blew my mind and changed my thinking about how we think about these things. And I was just in awe, and I said, I have got to meet this woman. And we've been having fun ever since. Anyway, so today she is here talking about, I'm gonna let her introduce herself. She is currently a professor at University of Colorado in Boulder, and she has been she's been doing a lot of innovative research. If you have LAs at your university or school or are familiar with the LA program, that was her idea, and she made it work, and it's amazing. So, hi, Carolyn. Anyway, so Valerie, if you would share your screen and get started, introduce us to you.
Right, share. Okay, I gotta tell it to a slideshow. Does this work, everybody?
Yeah, do you have your title? Do you have a title page?
No, this is it. I'm going generic now. I could add a title page. I just made the exec decision not to put my name on it. But this is
Okay.
just my title page, actually. It's just a picture from some of my video editing software. And shall I just start? Can I
How
start?
about you introduce, hi, I'm giving a talk my talk is entitled this.
Oh, okay. Yeah. Well, I guess I don't have that. I'm Valerie Otero. I'm doing a talk on qualitative research. I know that there are interests in what makes a qualitative research project. How do I review papers that have to do with qualitative research? What makes good versus bad, or PER versus non-PER? And I'm hoping to talk about all of that today. Does that sound like the kinds of stuff people are interested in? Okay, thank you for nods and thumbs up. I appreciate it. Yeah, no, I just went without a title page. I'm sorry about that. No, this is some in vivo software that I used to use, and I really appreciate being here because I'm very interested in reigniting with my passion for qualitative research and video data analysis, and specifically. And this video that's here, these are two elementary teachers that are in my physics class that are looking at video of students doing physics, elementary students doing physics, and analyzing their behavior. And because I know that by doing this qualitative research, you really can learn a lot about your students, about the learning that's happening in that class, and it really blows your mind. So that's what I'm going to do today. And I'm going to start right now. So today I'm going to talk about research methods, conceptual frameworks, theoretical perspectives, coding and cautions, and representing and explaining the data. Oh, I should say, I'm going to spend the first little chunk talking because I think it's important, and then you'll look and just notice some trends in data. And then all throughout, I'll be talking about what makes quality research. Okay. So, okay, now if you're interested in doing qualitative research, or if you're reviewing a paper of qualitative research, you're going to run into words that you never even knew existed. And look at all these words: semantic relationships, contingency, paths of connectivity, phenomenology, hermeneutics, semiotics. All of these are going to show up in something you review, something you read, or even if you're looking for a methodology. But some of them have big differences from one another, but most of them have subtle differences from one another, and some of them aren't different at all. So what I'm going to talk about is generic inductive analysis, which is mostly what you're going to see in PER. So the video that we use, I mean, the data that we use typically in qualitative research is like either long answers from surveys or these transcripts from either audio or video. And these are two different ways that people represent transcripts. You should know that there's a lot of transcripts. Look at this. This is activity 2 of 1 of 6 chapters in a semester. And it's only one activity. And look at all this. There's 17 pages of transcript. I mean, there's a lot of data to analyze. And I'll show you later an example of an analysis of like 6 activities. How do you represent that and try to help the reader understand what it means, and how do you evaluate whether or not that author has done their job? So the purpose of generic inductive analysis is to condense extensive and varied raw text data into brief summary format. I mean, you have to. You're not going to present 17 pages. And oftentimes we refer to this as a descriptive model. And then the other is to establish explicit, I should have made that bold, links between the research objectives, the summary findings, and the data, and ensure that those links are transparent and defensible. I'll show you a little more what I mean, but it's connecting the dots for the reader or the reviewer, helping them understand how this claim came into existence, just like we would do in physics. And then to develop a clear description or explanation of the phenomenon that you think you've observed. Sometimes people just publish the descriptive model, which I may show some examples of in a minute. So qualitative research is straightforward, right? Research to collect data, code data, categorize data, represent data, explain data. And then it all has a theoretical framework. I'll talk a bit about that and the role that it plays in qualitative research. No, it's not straightforward. It's not straightforward at all. When people do the research, it's more like there's a theoretical framework looming in the background somewhere. You're not even sure what it is because it's like going out into a garden to see what's there. You don't really know necessarily what you're going to find. And then you collect data, you return and change your research idea. You collect more data, you code the data, you categorize it, you represent it, collect more, or code it again. Usually code it again. And you go through this process quite a bit and eventually end up with something. And I'll show you some of the things that people ended up with in going through this complicated process. Now, you've gone through this, but you have to represent it, or you have to review somebody who's represented it in a very straightforward way. So I want to say something about conceptual or theoretical frameworks, which I'll elaborate a little bit in a minute. And if you have questions, I guess feel free to raise your hand, because I didn't know where I was coming in here at. But Margaret Eisenhart says that, and this is really important, is that a researcher cannot simply just describe or identify data in terms of a framework or a theoretical framework, nor can they unquestionably accept a predetermined framework. Because either would be to assume rather than to demonstrate that the explanation that you derived from the framework is adequate. So this whole presentation is about how do we demonstrate that what we think we see as it relates to a framework and as it relates to the data is the best job we could do and is publishable. And there's three types of frameworks generally that you'll see. You'll see a theoretical framework, you'll see a practical framework, you'll see a conceptual framework. And honestly, people use these words differently. In fact, I'll use one word differently than the authors I'm talking about used it. But the theoretical framework uses like established coherent perspectives in the literature, like they write about constructivism. Here's what it is. Here's how it defines learning. Vygotsky's theory of concept formation and resources. These are all theoretical perspectives that are written about in the literature. The advantages are they help us communicate because we all know, oh, you're using constructivism. I understand what you're saying, and I can map from what you're saying to that theoretical perspective. And but it also strips the data of its context and local meaning, and sometimes is not functional in the discipline or in the day-to-day practice. In the practical framework is constructed with practical improvements in mind. I want my students to learn better, this concept. And the findings inform practice, and the perspective is informed by practical knowledge and prior research findings. So an example of this is like student difficulties, misconceptions, and I have resources in two places, I know. But this, our whole discipline, PER, is built on people studying what students had difficulties with and how we can help them get over those difficulties. So, and it's got practical application, but it doesn't have like a way to build a theoretical or unified generalizable theoretical perspective on learning, and it maybe doesn't want to. You know, these disadvantages don't discourage me from using these different kinds of things. It's just knowing what you're getting into and what you're reading about. And then a conceptual framework is where they bring different theoretical perspectives and put them all together. And then you have to talk about the explicit connections between these perspectives and justify why you're using all these three. So I'll show an example who uses resources and this new sense-making perspective that's in the literature now. Has a lot of advantages for flexibility and discourages unwarranted conclusions. It discourages you from trying to fit a square peg in a round hole with a theoretical perspective. So I'm going to talk about three papers. Here they are. These are the recent. This one, top one, was published in 2025. You can see that they're all from the same research group. Some authors went in and out, and sometimes it seems reflected in the paper. But what's important here is that all of these papers built on each other, almost using the same data. And if any of you are here, if I misrepresent anything, just do let me know. But I consider these to be examples of exemplary qualitative PER, and that should be published in a physics journal like Physical Review. So I'm going to talk about all of these. The first one here in 2023 uses a resources framework, which I'll describe a little bit in a minute in case you don't know. And then the second one also, so the first one is like, how do you look for resources in students' reasoning? And the second one is, let me show you what we did and what we found. And the third one actually brings together, it says, okay, now let me figure out what learning is all about if I could use the resources perspective and this new sense-making perspective. So everybody okay? I only have a few of you in my field of view. Okay, so resource theory in a nutshell is it's instructionally significant, and it's really looking for seeds or beginnings of formal physics understanding that can be built on to help professors learn. You're not looking for whether the students are right or wrong. You're looking for what do they know that's useful. So the example that these authors give is forces influence the motion of objects. And I mean, that's not Newton's law. That's not Newton's second law. It is something that is useful now that we know they think that way. I put this one in from my research in purple. The ball stops because the force ran out. And I mean, you have this urge to say that's right. But you know, if you look at it closely, it's like an energy idea. It's like the energy, well, it doesn't run out, but it changes forms. And so that's what the resources is all about, is looking for useful things that students say. And then using the perspective needs to be theoretical consistent. That the theory is that students have ideas that are generative about physics, whether they're right or wrong. They're dependent on context. They're not like, they don't carry them around and use them consistently necessarily. And then even resources comes with kind of a definition of learning in terms of the activation of resources. And then it's accountable to the discipline. Like, these papers need to draw on time-tested tools and knowledge. Let us know what you're drawing on, students' difficulties and misconceptions, but it does always frame students' responses as continuous with formal physics rather than focusing on what students don't know. Okay, so here's an example from this paper. This is the 2024 paper. Those were from the 2023 paper. Now I'm going to give you an exact example of what they did and how they did it. Okay, so they gave them the students, they gave them 5 electricity questions and 5 different types of electricity questions. And they analyzed a ton of data of students talking about their solutions to these problems. And they were looking for resources. Look, the study here is finding conceptual resources and of electric circuits. And actually they were looking for common resources, ones that were common among the students. And so here's their findings. I'm going to show you their findings first, and then I'll show you how they got them. But it's important. So they really came up with only 2 resources out of this amazing large amount of data, because they did their homework. And so Ohm's law trio, they called it, and it's 3 different kinds. Like they think these are all related to the same idea. Current is responsive, voltage drives current, and resistance limits current. These are words that summarize the things that students articulate. And knowing that they're thinking this way can help curriculum developers and teachers. And then I guess there were some examples of students using all these 3 together. And then they came up with another common resource, or they claim is a common resource in the paper, that it's called connections, and that to the way that elements are connected within a circuit matters. So, I mean, this isn't a physics idea, but it's really something, a formal physics idea, I should say. But it is something that is useful to know, that students come in with, that we can use to teach. Now, let's see how they got these, okay? And I literally took pictures. I took screenshots from the publication, because I think it's important to see how this is represented. So here's them presenting their method, okay? And they've already presented their method abstractly above your monitor, no, in the pages prior. And they say, to illustrate this process, the thing I just described, we use the constant comparative method, all that stuff, those fancy words I showed you. And now they're saying, here's what we did in the particular, in these questions. First of all, they present some of the things that students said. And then they say, in the first pass of this analyzing this question, we might flag that the first response includes this productive idea or resource. And then they said, we continue through the data, and we also note these kinds of responses. And then they say, the first response includes this. The second response includes that. The third response has this idea. So they're telling you how they're interpreting the raw data. So this is helpful. It's not just they're saying, oh, hi, here's these resources we found in the data. They're telling you how they came to get those ideas. They're connecting the dots for you. And if it's a mystery, then it's a problem. And so then they go and they say, okay, look, we could have coded these. We could claim that all of them, let's see, let me read this just full on. We could categorize these ideas in a variety of different ways. We would claim, however, and we are claiming, that all of them relate to how elements are connected in the circuits. And so this gave rise to that connections resource that I talked about earlier. So see, they went through all the data. They were explicit and transparent about what they did, and you can follow and you can decide if you feel like their analysis is good. And now here's them with presenting their results. Now, this is just the current is responsive. That's just one category of the big Ohm's Law trio resource that they found. And they don't just say, I just recently read a paper where they just told me what they found in the data, and I never had a chance to know how come I should believe you, you know? And here they describe the thing that they think it is. They give examples of what they think it is, and then they demonstrate why they think that these examples are what it is. So if you can't connect the dots as a reviewer or as an author, then how do you expect the other people to believe that your research is valid? And so in this case, I think, and you guys can go grab these papers and read them yourself, they did a very good job in justifying what they did, how they did it, why they did it, when they did it, and the results that they came to. And remember, they called these things common ideas? Then they went one step further and they showed us the frequency, the percentage of students who used these ideas in these five on the y axis, these five types of questions. So this then justifies their claim that these are common ideas, okay? And they can set a threshold. They can say, we consider an idea common if it contains at least if 10% of the response is included. So I guess the point I'm trying to make is these papers are making a claim and they're supporting it with evidence, just like we do in any physics study. Okay, so then in their 2025 paper, this is another for all you authors out there, look what you can do with one data set. Like you can really do a lot because this data is so rich and it could last a lifetime. But what they did now is they added a new theoretical perspective. So now we call it a conceptual framework. They added this sense-making framework, and I used it, and I'll show you some examples early in 2004. But it is now evolved into a legit theoretical perspective. And it just basically says that when we find sense making, it occurs in response to ambiguity or uncertainty. It's an active process of meaning construction. It's deeply situated in learners' embedded contexts, and it's rooted in social interaction and negotiation. Now, these things, of course, were found in this paper. I found them in this paper. I summarized them, of course, but they're telling you what theoretical perspective they're using, and now they're going to demonstrate and not assume that the explanations that they generate are reflective of that perspective. And so just briefly, here's their 2025 paper. As always, they present the transcript. We need to see the raw data. I don't know how much I would trust something that didn't give me at least some raw data and not just the summary and not just the codes, as I'll talk about later. And then over here in the bottom, they provide a clear analysis of what they think is going on in that data. And then you, as a reader or a reviewer, can look at it and say, I think I differ a little bit, but let's see, what else do you guys have, you know? And you can follow, they've connected the dots for you. And then they did a mixed methods. Some people would argue that the other paper was a mixed methods, but they did a mixed methods here because they're ultimately going to argue that this sense making is worth something. It's valuable. It's really all that matters. But then they said, I bet you our readers or reviewers are going to say, but did they learn anything? And so they present, after making a big argument that sense making is the most important thing to them, they then present this pre-post analysis where you see that the percent correct not only increased, but they were able to demonstrate which one, how many initially incorrect turned into correct. So this is a mixed method study. So now you're responsible as a reviewer for both looking at at the quantitative and the quality of the qualitative data. And then their ultimate, not ultimate, but part of their explanatory model that they came up with was, look how they are explicit in saying, at first they say, we're not claiming that the students didn't know then and they know now because of the curriculum. But what we are saying is that they answered in a way that reflects what seemed to be a group consensus, which we think is a result of and responsible for their shared sense making that affected the thinking possibilities for all group members. And that's what we value. So they've told you everything. They've told you what they think is important. They've told you what they think you might think is important. And they've justified themselves every step of the way. Now, let's see, where do I go next? Okay, I'm going to give another example of representing and explaining data, but are there any questions at this point? If so, I think if you raise your hand, you raise to the top of something relevant to the stuff I said.
Valerie Carolyn has a question.
All right, Carolyn, what's your question?
Carolyn, are you muted? She's in the chat. She asked the question in the chat.
Oh my God, help me, please.
I think she asked if you are going to share the slides later.
Oh yeah, sure, absolutely.
Yes.
Yeah. Rebecca will help me with that. Okay.
She's eating dinner.
Okay, wonderful. I hope it's good. So I'm going to show you basically the same argument I just made, only with pictures and with a lot more data. And I don't even think it's a lot more data. It's more data over time. But just to bring the points home of how can we map what these people are doing and judge whether it's quality, and the hardest judge is going to be yourself. If you can convince yourself that you're saying something, then you could probably convince others. So this is some examples from my early research. And what I'm going to talk about are these. We have this simulator. Before I show you the representations, I just need to tell you what I'm talking about. We had these real simple simulators that when you rubbed insulators together, they got red, one got blue, and they got blue thicker and red thicker the more you rubbed. And they also had these soda can electroscopes, which is a can on a styrofoam thing with tinsel, and it's an electroscope for all intents and purposes. And anyway, that's what they're going to be talking about in the data I'm about to show. That's so very similar to the work I just talked about. So the resources that I looked at, you guys saw those for current electricity, was electrostatic charging insulators by rubbing. And you could see the students' diagrams, and you could see this person says charges are given off, and they show like a little picture. But you can't just say this person thinks charges are given off. You have to look for multiple examples, either in one setting or over a period of time, to be able to say this person seemed to have this idea for this time. And this is what I called the atmosphere model. Charges given off. Another person had a two-way transfer model. Positives go one way, negatives go the other way. Another person kind of combined them both, that when the positive charges went on to the other object, the negatives spit out into the atmosphere. So these are ideas. None of them are right. The right answer would be a one-way transfer model. Electrons transfer from one object to the other during rubbing, leaving one with an excess of positives and the other with an excess of negatives. But these are all good resources. I could use these to help these students learn. But I was the researcher this time, so I didn't have to. Okay, so now how do you represent these ideas? So back here you see basically three different ideas. There was a lot of different ideas. So look at all these. They started with stuff like even charge creation. When you rub them together, charges are created. And so these are the kinds of thinking that students go through in the learning process. And all the way to the top, which is the right answer, if you will, the one-way transfer model. So this is a group, MJH, those are 3 students, and the triangles represent H. You can see that they're the 3 students, as their ideas were identified over time. And this is a different group, PRT. So I want you to notice trends, and I need you to help me. So you're going to have to take a bite and tell me what you think. What trends do you notice in these data? And I'm going to ask you to either yell out. Yeah, yell out. Don't put it in chat because I can't read it.
Well, what I'm seeing across both data sets is that if you just focus in on any one student, there does tend to be a trend as time goes on for them to rise up to these higher, or at least the model profiles that are listed higher. And I'm assuming that they did so because these models are, in some order of heading towards that normative one-way transfer understanding.
That's a great point. So how come they're ordered that way? That's the most controversial part of this research is they're ordered that way because a group of people determined increasing sophistication towards the one-way transfer model. And we do see that over time on the x-axis. Anything else people notice? All right, I'll tell you what I noticed. That was pretty good wait time, I'd say. What I noticed was in the early stages of the unit, they had different models from one another. And near the later stages of the unit, they had the same models as one another. And that's interesting. And so what questions might you ask if you notice those trends?
I would be curious if the students had been engaging in any sort of like argumentation with each other where they were each proposing their different models against each other, and if they were convincing each other to move into one of these other model profiles.
Okay, that's great. So I'll summarize that as a kind of a version of what I asked, which is how did this convergence happen? How did they come to agree with each other? Did they read the text? No, there's no textbook in this. It's all just analyzing data and consensus. So yeah, let's find out. And so if you look at the next thing I looked at to try to answer exactly that question is I said, okay, what kind of like you just said, what kind of argumentation did they engage in? And I had already coded everything with model-based reasoning, experience, all these things. And I decided to categorize these as sense making. And that was before the literature started talking about it as a theory. And then in category 2, you'll see there's a whole bunch of stuff that I coded, and most of them I didn't even use. So what I ended up using to try to answer that question of what happened where they got to the same place was sense making, and then this laboratory and simulator. And these two codes, I coded it when they were doing sense making about the simulator, or when they were doing sense making about the laboratory apparatus, which was that soda can electroscope. And let's just, let's go exploring and see what we find. And that's what we do in qualitative research. And so look at this. This is, again, it's weeks. It's like 2 months worth of data. That's 250 pages of transcript. And I looked at the percent of time that the students spent sense making out of the 60 minutes that they were in class, what percentage of time was coded as sense making. So what trends do people notice here? And these are the names of the activities. They're named.
Valerie, people are sharing questions on spam
Can you
or
read
on
them
chat.
to me? Yeah, because I can't I don't for some reason.
Yeah, I will do. I just wanted to let you know. I'm gonna go with the most recent one. Okay. So James Freericks says, I found it interesting that initially no one had the right idea, but then all converged, about at different rates to the same correct interpretation. And I believe if that is about the last one, then I will also have some other ones that come up. There's a whole big discussion on chat for this.
Okay, awesome. It'll be transcribed and I'm very much looking forward to it, but don't hesitate to read those out or speak out loud so I could hear it. For some reason, there's no chat on 2 screens that I have. Okay, anybody got some things to put in the chat for Rebecca to read for any trend that you might notice here?
They spend more and more time on sense making?
Later on in the semester, there seems to be more sense making going on, doesn't there?
Right.
Percentage of time in class spent sense making.
And Carolyn also mentioned that more time in later weeks, sense making.
Okay, perfect. Thank you. Yeah, it looks obvious, right? And then when I went and said, what the heck happened in that 2D3 activity? Oops, sorry. And that's when the simulator was introduced into the curriculum. So the first thought is, can you imagine somebody giving you this data and then telling you the simulator caused them to increase sense making? And that's I don't know. Are we sure? Let's go. We've got the qualitative data. We've got 250 pages worth of transcripts. Let's go look. And so then I just took from 2D3 on to the end and I separated. Remember I said I coded everything with sense making with laboratory and sense making with simulator. And I split them out and looked at like how do they look different, what happens? So here, the trend I noticed, and that I think you might notice too, is it looks like the simulator sense making was only higher at first, but then the laboratory sense making started to get higher in both cases.
We have a comment from Brian Lane saying, I'd have thought that that's when midterm grades were posted.
Mm.
And then Jared Arnold responds, that could be a confounding variable.
It very well could be. And if you have that question, that's exactly what you'll ask them if you're reviewing the article. You know, what other, because that's another rule of qualitative research. Have you presented other possible arguments and have you tried to refute them? And just to finish this, then I superimposed that original data of their models with the sense making data, but I had one of them by activity, the other by date, so it looks a little different. But here you could see that there was a point at which that when their models converged, that's when the laboratory sense making was heavier, and the simulator sense making went down. So now here's an example of an explanatory model. Here is an important point where their models converged. And the simulator reasoning was generative. This is an explanation that, it was my explanation. Doesn't have to be the right one, but it was generative as they negotiated terms when they weren't even talking about the same thing. Their models were different. Some of them used the word they to refer to the straw in the soda can. Another person used the word they to refer to the electrons and protons. And so when they didn't have shared language, the simulator seemed to mediate their generative sense making. And then they would just go to the laboratory to confirm it. And then after they had a shared model, and you heard the Robinson group was talking about how important that convergence or consensus model is, they no longer needed that mediating artifact. And so they were able to talk directly about the physics on the laboratory apparatus. So, and then they tested their conclusions on the simulator. So just to finalize, oh yeah. So just that the roles of the tools changed as the students' ideas changed. And then I did a smoothed averaged curve. And this is, you can see there's a lot of things you could do with a bunch of pages of transcript. And in the early part, they were doing mostly before the simulator, experience-based reasoning. And then when the simulator was there, they were doing model-based discussions that were mediated by that color scheme and the thickness of the lines in the simulator. And then they once they had the same models, they were able to reason with the laboratory apparatus. And this was one of my final fun, way of representing a ton of data. And you see that in the start of the unit, the simulator had a generative role. At the end of the unit, the laboratory had the generative role. And the claims are that the simulator mediated the development of a shared model and mediated the scientific practice of reasoning with laboratory evidence. And anyway, so there you could see how the way I justified the claims was by getting the coded data and placing it on graphical representations and coming to a conclusion. But in the same way as the research group I talked about earlier did, everything was made explicit. And by the way, I ended up using Vygotsky's theory of concept formation, although that's not what I started using. It wasn't until I understood how important that mediating role of the tool was playing that I had to go searching for a theoretical perspective that could help me. But then you have to connect the dots for the people. So I want to take a moment now, entertain some questions. Actually, before I do that, I want to show you a few. Actually, I'm not. I'm going to stop sharing my screen for a minute and entertain questions that you might have about your own research.
And again, if anybody puts them in chat, I will let you know.
Thank you. Surely I haven't answered them all. Oh, I see the chat now.
Oh, you do? Okay.
Mm-hmm.
But I have trouble paying attention and answering questions directly and paying attention to chat at the same time. So okay.
Okay, I'll ask a question.
Please do.
So Valerie, when we talk about theoretical frameworks or conceptual frameworks, it took me a very long time to understand that the term theoretical framework in educational research has nothing to do with the theory in physics. And that was not explained anywhere because everybody uses like, what's your framework? And what the hell does this word mean? And I wanted to run it by you if you agree that the word framework in this context, theoretical, conceptual, practical, whatever, means a telescope that is sensitive to certain things. So it's like a lens through which you can only see UV, or the lens that you are using to, not the lens, but an antenna to get the radio waves. And that's how you are approaching. I'm not focusing on visible light. I am only studying the radio emission. And,
Absolutely. Oh.
and so understanding the word framework as a telescope or a specific lens, and I think lens is worse than the telescope for physicists, because physicists understand this is a radio telescope, this is an infrared telescope, and this is an X-ray telescope. And an X-ray telescope does not see visible light. And so once we understand it, then we start using this terminology of a framework in a completely different way. Then we understand why Valerie used the framework, Vygotsky framework, later, but not at the beginning, because she has the data, but that telescope that she had did not allow her to see certain aspects of the data or certain patterns. Once she has a good an appropriate telescope, the patterns emerge. What do you think?
Okay, excellent analogy. Of course, with limitations. Excellent analogy. So this brings up, though, a really important thing is like, and is like I put with the pros and cons of these different perspectives. If you, I have a student, I have a situation right now where when somebody is so dead set on using a perspective and then they create a survey, and then the survey is almost designed to elicit the responses that will fulfill the needs of that perspective, that's not PER. It may be critical theory, but it's not PER. And so it's very important. And that's why grounded theory is kind of, and the word theory is so differently used in qualitative, but I need to point out for any of you who find yourself reviewing an article or writing one, that this is normal terminology. And I used perspective for so long just to avoid the word theory, but because of that, but I'm seeing it everywhere in phys rev, and now I'm feeling like we got to address this and own it. But yes, you could come in. I came in with a whole different lens. I forgot what it was already, but when I started looking at the data, I was like, I just threw it out and did what they call grounded theory, which is where you go into the garden and tell me what you think you see, and then when you start to say, I think I see somebody doing model-based reasoning, I think I see somebody doing experience-based reasoning, and then when you start to describe what you see, and then you can then find a theoretical perspective that might help you, and so that might help you communicate what's going on. And so, yeah, if you start, that grounded theorists argue that you shouldn't even read any research papers before you do it, because that way it'll contaminate the way you view the data. But yeah, so oftentimes, though, you may intentionally say, I want to look at the gender negotiations in the classroom. I don't give a darn about the physics learning. And so but you may need to pay attention to certain things that are going on. So yes, a perspective is gonna be like a telescope, and it will be refined as you continue to work. And if you're not refining it, you might be sticking so strong to it that you're forcing data into an answer and that's not, to me, research. I mean, even though there's a lot of it out there.
But I think it's important for physicists to understand that the word theory or theoretical framework has nothing to do with our understanding of theory, especially in the words grounded theory. There's
It's
no
a grounded
theory there.
theory into developing a theory that is
Yeah,
grounded
it's like
in.
you induce a theory from, so it is actually a little more like the physics theory word, because you look at the data, and by working, you make inferences that would lead to an explanatory model. I would go as
Right.
far as to say
Right.
explanatory
But
model.
if it was called a model, I would agree this is physics terminology. but we think of a theory as something that has been experimentally tested in multiple contexts. And so that's not what it is.
This is going to get, so buckle up, because you're
Yeah.
going to see this word used it is. I showed you papers that use the word resource theory. And I hadn't used the word resource theory. I had kind of used resource perspective before, but it's there. And so just hold as you're reviewing articles that this is a real conflict. And when I write, I'm hoping physicists will read my articles, physicists that are not PER physicists. And I don't want them to get confused, and I don't want them to negate the quality of my research on the basis of a terminology.
Mark, David's has his hand up.
Thank you. Pardon my ignorance, but let me share a quick story and then ask a general
Please
question.
do. Thank you.
Way back in the mid 80s, that's 1980s, Goldberg and McDermott published something on misconceptions about real images created by lenses.
Yep, I know the word.
And after Goldberg's presentation at the national conference, I went up and talked to him and I said, Professor, I think my results will be entirely different from yours. 80% of your students miss this question, and I think 80% of my students would get this question. And he said, no, that's not possible. I have research over 5 years with a $10 million grant from the NSF. And I said, okay, well, let me go back, and I've done optics a month ago. Let me go back and ask the questions that you've asked in terms of the misconceptions. And I did that, and sure enough, a month after the optics unit, the students still scored 80% correct, whereas his students were getting 80% incorrect. I shared my results with Paul Zitzowitz, the late great Paul Zitzowitz, some of you might know.
Oh, yeah.
And Paul said, well, you're certainly correct. He said, why don't you contact Dr. Goldberg and tell him? And so I did, and I showed him the technique I was using, and I never got a response from Mr. Goldberg. And so I asked Paul Zitzowitz, I said, Paul, why didn't I get a response from Dr. Goldberg? And Paul told me, well, all of his money is coming from identifying misconceptions, not in correcting them. So which is probably true. I mean, Lillian McDermott and Fred Goldberg were at the tops of their game back in those days. And so my question is a general question. Is the goal of PER to identify problems or misconceptions, or is it to improve instruction to prevent or minimize those misconceptions?
Well, a lot of people in PER don't use the word misconceptions because sometimes when we use that word, it feels like the student has it. And the way this resources model was a reaction to misconceptions, because it's trying to say they're context dependent. Sometimes they say the force ran out, but other times they say, something must have been pushing against it to make it stop. And so that was one of the problems with the misconceptions research, was that we couldn't necessarily be sure that this was a context independent issue. But what is the goal of PER? I think that's up to us to decide. And I think that it's up to us to, when we write our papers, just like I was showing you with that group of papers, to be very explicit what you care about and what you're trying to do, and then to map that back to your data so that we're able to say, I could do this study too. And if I did it, here's the results I might get. And so that's our job, is to be very clear about, like you even saw, I mean, if you read that 2025 paper that I showed you earlier, they sit there and say, we don't really even care if the students learn physics. We just want them to be doing sense making. Okay. We'll show you that they actually did learn, because we think that sense making is, correlated to learning. So I didn't mean it quite that strongly, though, that they don't care, but they make it clear that sense making is their goal. And so it's up to us to be explicit about that.
Mark, you have
Yeah, one quick comment. I recently put together a paper with another gentleman regarding misconceptions from a single lens and real images, and to the Physics Teacher magazine, and they sent it out to 3 reviewers. And one of the reviewers said, what you're saying is not correct, is not possible. One of the reviewers was skeptical. And during the interim, we've already shown this to several meetings of physics teachers, and they've all seen that you can actually, without a screen, you can see a real image formed by a single converging lens. And so it's a little disappointing when something like the physics teacher asks for reviewers and half of the reviewers don't think what you're even talking about is possible. And I don't know how to get around that. Any suggestions?
Yeah, be explicit about every single, everything you have. Show them your data, knock them out with it.
Okay. Just to check with the AI, Chat GPT, I asked the same question. Can a single image be formed with, can you see a single image, a real image without a screen? And GPT said, no, of course not. And it took, I did the deep search. It took a long time for it to come up with that answer. And so with a number of follow-up questions, they started to hem and haw and said, well, we're not really quite sure.
Okay, well that's all very interesting, and it's interesting that there is a phenomenon that's interesting. But what we're talking about, I think a lot of what's important is how we report, how our data about student learning, about curricula, about findings is connected to the findings that we're doing. I want to make sure and leave you with another important paper, a couple things that we need to know. Am I sharing my screen?
Yes, you are.
Okay. So this is yeah, so this is like this is Hammer and Berlin. Please read this paper. Because they're again talking about some of the roadblocks that you might run into as a qualitative researcher or a reviewer. First of all, they state two standards. I've got another whole paper full of other standards, but this one basically says the method is sufficient detail for the readers who wish can apply your method, and that you provide a body of data that is large enough to allow the reviewers to analyze it on their own, to make sense of what happens, and even to agree or disagree with the way the authors described it, because it's iffy. It's not perfect. And so I think those are excellent. And then they go on to say, I'm going to read this whole thing because it's so important. I talked a lot about codes today. Many articles, like I coded metacognition and all that stuff. And what happens a lot in qualitative research articles, please watch out for this. Many articles do not meet these standards, he says. They say instead, the typical practice is to describe the coding scheme, to illustrate it with a couple examples, and then to present all the results in terms of codes. And just in terms of codes, and often in tables or numerical results in various categories. When articles give only brief illustrations of the coding, they are effectively and often explicitly treating the results of the coding as data themselves. So that's just another thing to be aware of. Is somebody says like what I showed you with my stuff near the end, I just showed you all the codes and what I did with them. But I hoped to demonstrate that in the rest of the remainder of the paper, that level of transparency and articulation that you saw in the Robinson group is there. Does that make sense? Don't confuse codes for data. I'm having a little network instability, so sorry. When did I lose you guys?
You're okay. You didn't lose us.
Oh, good, because you guys are moving slow, but
No,
Do
you
you
moved
have a
fast.
response, a question on that statement? I just have to get to it. Okay, Catherine Crouch asked, if the data required to do this are very lengthy, should they go into supplemental
yeah.
information?
Yeah, supplemental narratives that are now available online, so you don't have to throw them in the paper. Absolutely, what you do. In fact, I've done that before. It's like this is too much and TMI, but you've got to make it available so that the readers or reviewers can at least have a place that they could go to trust you, and they need to know how you trusted yourself, that what you think you saw was there. It's not quantitative research where you can know very precisely everything about nothing. This is this is qualitative research where you know nothing about something, but you try to blend the case. I think I saw this. I saw trends. So here's one from Huan. In Korea,
Yes.
teachers tend to rely increasingly on simulations for the sake of convenience, and they call it online experiments. So based on your research, finding simulations seem to serve as primary mediating tools while the role of hands-on experiments remains crucial. Yeah, I mean, I didn't make that claim, but I do think that, well, I don't know, 9/11 was only people who learned how to fly on flight simulators. So I don't really know if I don't have an answer. That's an empirical question. How important is laboratory evidence?
Uh, Valerie, I think it's important to, I don't know, you've been emphasizing it, that the conclusions that you draw are only based on your data and that you're not generalizing. So the question that is posed is about generalizing something that you do not wish to generalize in a qualitative paper, because all your conclusions need to be tied to the evidence that you collected. And the evidence that you collected does not allow you to make this conclusion.
Absolutely. And honestly, I feel like that's why I spent a lot of time on those 3 papers. Like they said very clear, we're not claiming that the Acorn, curriculum took them from not knowing it to knowing it. What we're saying is we show you that they know more at the end of the semester. It could be maturation or any kind of factor that built into it. What we're showing you is that they did engage in good sense making, and it's reasonable to think that there's some connection between the two in this circumstance. But I do think that we should be comfortable thinking about ways to like that's what they're doing with the resources, is like, look, these seem to be generally applicable.
Well, everyone, it's 6:57. We have time for more questions. I just wanted to let you know what the time was. Valerie has a movie to show us of something.
Oh no, we don't have time for a movie.
All right.
Yeah, but I'm happy to show it at another time. I just thought we might need some time to analyze it, but I think that this discussion was so rich that I'd prefer to, just make sure we got 1 minute. Anybody got something?
Valerie, I have a question. So you are going to send me or Rebecca the slides, so we can share the slides and we will share the recording. But there's a really important question here. How do you go about selecting methodology for qualitative research from the many that are available? Could you comment on the use of software tools and such in Vivo? And I recommend MAXQDA. So that's, I think, is the question that you can still answer, right?
Yes. Yeah, it was answered by one of our amazing colleagues. Here, take a screenshot if you guys want. Well, actually, I'll just send the slides. I'll be in touch with you, Eugenia. You've been in touch with me.
Yes.
I'll send you the slides, and
I think the recording will have the slides on the screen and have Valerie talking on it. So we will see everything she showed on screen.
Okay, and then I also have like David, Danielle, and I recently did a qualitative methods in PER paper in 2003 in the International Handbook, and so that'll be in the references at the end of the slideshow.
You said 2003, or do you mean
Oh wait,
2000?
here, let me put them on the screen so that in case in case somebody doesn't here, in case we need it, just so it gets. Are we still recording?
Yes, we are still recording.
All right,
Yes.
here's all the references that I used, but the one on top I didn't use, but this is one of our methods articles that we recently published. So that'll be available in the package of slides as we move forward, and we'll do that.
Well, I would like to thank everyone and to thank Valerie for a wonderful, as I told you, she's a firebrand. She really understands this stuff and helps convey it to us. So
do you
yes, I
all.
would like to thank you, and I really appreciate you coming, and thank you everyone else. And I wanted to let you know our next community conversation is on November 19th, when Tim Stelzer is going to be talking about quantitative work and stuff like that. So be looking in your communities and other links to get information on that, or contact myself or Eugenia directly.
Yeah, I post nonstop about the coming up events multiple times. So if you missed one, you'll see the next one, and Mike posts, and then we'll also have it, oh God, everywhere, like
We try to have it
email
everywhere.
to all AAPT members. So you're probably tired of these reminders, but this is for those who missed some, they will get some others. So don't worry.
Very deeply appreciate all the work you all are doing to bring us together. Thank you so much, everybody. This was amazing, and I'll see you at the next one.
Yes.
Thank you so
Thank
much,
you, Valerie.
Valerie.
All
That
right.
was great.